All right, what's up, everybody? Today we're going to learn how to integrate by parts. And today I have a really good example that shows kind of a problem with double integration by parts. We're going to integrate by parts, and then it's going to result in a function where you're going to have to either use sub or integrate by parts again. So let's get started. The general rule for integration by parts comes with an equation that looks something like the integral of u times d to the v equals u to the v minus the integral of v times du. So this right here is the problem they're giving you. And from that, you're going to identify what's u and what's d of v. And then you're going to kind of find your other equations that you don't know. So they gave you u and they gave you dv, which you identified in the equation. And from the dv, you're going to take the integral of that to find v, which is going to be used here and here. And you're going to take the derivative of u and you're going to plug that in here. So once you have that equation, your kind of master equation is going to go right here, and that's going to be your answer for these questions. Okay, so let's look at a quick, easy example first. Okay, we're going to look at a quick, easy example. We're going to look at the integral of x times e to the 2 of x d of x. Okay, so as you'll notice, you can't really u sub this because the e to the 2 of that x would be u sub, but you have an x in front of it. And if you were going to take the derivative of this, you would use the product rule, but taking the integral of this uses integration by parts, which is the integration version of the product rule. And usually what I found first, well, most interesting is the answers of these are usually very complicated. But let's look at a quick, easy example like this. Okay, so from what they gave us, we're going to first identify our u and our d to the v. Okay, so u would be whatever's first, which is x. So we're just going to write that here. U equals x. And our d to v is going to be e to the 2 to the x, which is right next to it. Okay, so now we're going to solve for our du and for our v. So our du, which is just the derivative of u, will equal 1, nice and easy. And our v, which is the integral of e to the 2 of the x, we have to solve. You would use u substitution for this, and once you u sub, you would find that this is going to be 1 over 2 e to the 2x. If you want to know u sub, you can look at a different video. Okay, so now that we have everything, all we do is we just straight up plug it into our equation up here. Okay, so we're going to do that. So this equals to u, which is x, times v, which is 1/2 e to the 2x, minus our integral of v, which is 1/2 e to the 2x times du, which is 1. So you'll notice that we have another integral to solve here. And this is nice and easy because this is just going to come out to, let's see here, minus the integral of e to the 2x over 2. And we can actually solve this kind of the same way. Well, you notice that over here, when we had u sub for e to the 2x, we got 1/2 e to the 2x. So if we're going to solve again for 1/2 e to the 2 of x, let me rewrite this actually to make this kind of just a little bit like last time. Then we're actually just going to end up with another 1/2 e to the 2x in front of it. If we take out the 1/2 and put it outside of the integral, then we're just going to end up with 1/4 e to the 2x. So as you can see, our final answer would be x 1/2 e to the 2x. You can put the x on top if you want, minus 1/4 e to the 2 of the x. And that's going to be our answer right here for this problem. Okay, now let's look at something a little bit more complicated real quick. And before we go into something that's a little bit more complicated, I need to introduce a little bit of a trick that's going to help you with some of these complicated integration by parts. And this is a rule called LIAT. Now, this is an acronym which stands for logarithmic inverse trig algebraic trig and exponential. So as you saw before, when we have to pick what's u and what is d to the v over here, then let's rewrite this down for a little bit more convenience down here. So we're trying to find, when they give us the integral of u times d to the v, it's actually going to equal u times v minus the integral of v to the u. So when we're kind of seeing what's going to be our u and what's going to be our dv, the order of this doesn't matter. So let me show you what that means. In our example we had up above, we had x times e to the 2x times dx. We could have used e to the 2x as the u if we wanted to, and used x as the dv, but this right here is going to give us the order of the operations that we need to use. And so whenever we're solving for the u and the d to the v, we're going to pick a u that is highest on order on this kind of acronym that we have. For example, the x was picked for u because x is algebraic. And and our other equation, e to the 2x, is exponential. So that's lower, so we would pick x for algebraic to make it nice and easy for us. Okay, now let's get into our final problem for today. This one is a little bit of a complicated one, but this is just going to give us, I think, if you know how to do this question, you'll be pretty good with integration by parts. Okay, so let's take a look here. So let's take number 2. We're going to look at the integral of x squared plus 2x times cosine x dx. Okay, now you guys are a little bit more familiar with this. We're going to go ahead and we're going to write down all of our unknowns. Okay, so we're going to pick, x squared plus 2 to the x is algebraic, cosine x is trig, and as you can see, algebraic is above trig on the kind of orders right here. Okay, so we're going to go ahead and write our knowns. U equals x squared plus 2 to the x, and our dv equals cosine of x. Okay, so our du is going to be 2x plus 2, take the integral of that, and our v is just going to be the integral of cosine x, which is sine to the x. So now we're just going to plug everything in. Okay, we're going to plug everything in. We have u times v, so x squared plus 2x times v times sine to the x minus the integral of v times du, right here, v times du, of sine x times 2x plus 2. And as you can see, we actually need another integration by parts right here, because the integral sine x 2x plus 2 cannot be solved very easily, and you can't really use, I guess you could use u, so far we're going to go ahead and use integration by parts here. So now is where this rule comes to hand in seeing what we're going to pick as our u. So sine x is trig is right here, fourth on it, and 2x plus 2 is algebraic, which is above it. So we're actually going to flip the order of this, and we're going to use 2x plus 2 as our u in this next equation. So when we do it again, we use capital letters. So let's go ahead and do this on the side. Our u for this is going to be, that's a little big. Okay, our u is going to be 2x plus 2, and our dv is going to be sine of x, which makes our du equal to 2, which is nice and simple. And the integral of sine to the x is going to be negative cosine. So our v is going to be negative cosine of x. Now we're going to go ahead and write everything back in this equation. Now remember, we're just solving for this right now. We still have this, but let's just keep this to the side right now. Let's solve for the integral of sine x of 2x plus 2. So we're going to go ahead and do that right under here, where we're going to find that it's u times v, so 2x plus 2 times v, which is negative cosine of x. And we're going to minus the integral of v times du, which makes it really easy because that's just negative 2 of cosine x. Okay? And this is actually a fairly simple integral to solve. Negative 2 times cosine x is just 2 sine of x. So we're going to go ahead and we're still solving for the right hand of our equation, remember? So we have 2x plus 2 negative cosine of x. And we're going to actually do that is negative 2 sine of x. Okay, and now we're going to just put down this down because we solved for the right hand right there. We're going to bring this down, and we have x squared plus 2 to the x times sine of x. Now, if we're going to put everything together, you can see that our two negatives right here create a positive right there. So final answer, the answer is going to be x squared plus 2 to the x times sine of the x. You don't have to simplify because this can't really simplify further. Plus, see the two negatives cancel out. 2x plus 2, it's going to be a positive cosine x minus 2 sine of x. And don't forget your plus c. Don't forget plus c. And actually, I just realized I forgot a plus c in the top right here. Plus c. Nice. Don't forget those plus c's. All right, and that right there is how you do integration by parts. Don't forget your LIATE method. It's really going to come in handy.